for a visualization of your code and whatnot. But primarily, we'll be dealing with Git. So if you don't have GitHub, no worries as well. So if you guys can go to your GitHub page, I'm hoping you all have an account on GitHub as well, along with your. Oh, sorry. So if you go to your account, first thing we'll do is first create a repository. So a repository is essentially where all your code goes. So it's like your hard disk on the cloud where everything is stored. So what you'll do is first create a repository here. So if you go and click the create repository green button here, so I'm going to call this Git training. And if you want to give an optional description, you can do that. And typically, if you have a free account, you'll only be allowed a public repository. You won't be allowed a private repository. But students get access to private repositories. I think you get 6 free private repositories. So if you're a student, you can get that as well from Git. And we'll leave this unchecked for now. And let's press create repository. So let's leave this page as is for now, because we need to come back to get this link from here. But much. So why do we use Git? First thing. So this is one of the SKC comics that tells you how hard Git is actually to learn, why people give up. But Git actually is easier than people say it is. But there are also complicated stuff associated with Git. If you actually want to learn, dive deep into it, you can do that as well. But on the surface, Git is pretty easy. So one way I tell people who are new to Git how easy it is, it's all you need is this cheat sheet, which is like 2 pages. That's about it. This is all the code you'll need to get started with Git, to use Git as much as you want, to collaborate with other people. Advanced functionalities, sure there are, but Google is always there for help. There are other sources that you can get help from as well. So I actually got through this by typing Git cheat sheet on Google. So if you do that, you'll end up at this page. And all the other links will also be posted after the class, so on the GitHub page for this particular lesson as well. So you can get these links there as well. Okay, so we have done. So one of the things, the reason I wanted to create the GitHub account is because if you need your username, email, and password to actually get started on your computer. So first thing what we'll do is choose any folder that you want. So I would say go to the folder of your choice. So I'm going to open any shell. I'm going to open a shell, and I'm going to say I want to, and I'm already at the folder that I want to be at. So if you can use CD to actually move to the folder that you want. So essentially, if you want to move to courses, to bring you to courses. So use CD command, get to your folder. And here what I'm going to do is I'm going to create a new directory. And I'm going to use the same name as the folder that as the repository we created online on GitHub. So I'm going to create a folder here. And this folder is already there. So this folder is here. So now what I'm going to do is I'm going to make this a Git repository. So the way you do it is the command called Git Init. I realized that. Okay. Is this visible now? Okay. So this command, sorry. So once you move into the directory, sorry about that. You move into the directory you create. Just move into the directory you create. Then type Git Init inside that directory. And this will change that into a Git repository. So if you type, and if you go into that, if you actually have your hidden folders enabled, you'll see a hidden folder called .git in the directory now. So this essentially says your current directory is a Git repository. So is everybody with me? Anybody not following? Which part?
That file.
Okay, so you initialized it, the Git training into a repository, right? You type Git Init. So now if you go to that folder on your Explorer, or whatever the equivalent of that in Windows is, on Mac is, so, and if you enable view to hidden folders, you'll see a .git folder there.
Okay.
You see that? So this tells you that the particular folder is a Git repository now.
And if we ever delete this, we have deleted our virtual.
No, your content is still there. So if you delete .git, the content of the folder is still there. It will just not be a Git repository anymore. You just sever the connection with Git. That's about
The
it.
last version will be there. But
Yeah.
we can't go back to our previous version.
If you reinitialize, you can. But typically what people do is they have another copy on GitHub. So if this is gone, they essentially create a new one, bring everything from GitHub there. So it serves as a current backup at all times. Okay.
It's not a disaster if we didn't realize.
No, it's not a disaster if you delete this. That's the whole idea of Git. If you delete it, it's not a disaster. Okay. Okay, so now what we'll do is we'll set the Git configuration for you to use Git with GitHub. So what you have to do now is essentially, if you type git config plus, you'll see all the available configuration options for Git.
That was Git config.
Yes, Git config. Stop me if I'm going too fast.
So I haven't changed my settings yet to see any folders. Is that like
wherever you want it to be. Yeah, wherever you want your repository to be. I just have my.
I don't want to just let some time to
you can use CD basically to move to that folder, but you can do that with Windows as well, with your Explorer as well. You don't have to do it on the shell either. Yes.
What is a Git config do?
Git config is for this particular lesson, the two important things that we are worried about is the username for your Git account and where and your password and your email for your Git account. That's what connects your. So we have two concepts in Git. So one is called a local repository, and other is called the remote repository. And what we created online when we started was the remote repository. So now we are setting the configuration settings for the local repository, so it enables it to connect to the remote repository.
So with Git config, can you set all those? Just
Yes, that's where I'm going next. So once you see the configuration option, so we'll set the username and the password. So what we'll do is, the next two lines that I'm going to say is not recommended if you're working on a computational server or things like that, because it essentially sets the options for all the Gits that are there. So if you're working on your local computer, the way I would do it is basically configure your username using the git config. Say it's for all cases, and you're setting your username, and within double quotes, you're in Windows, your username that you used to create your Git account. So mine is basically this.
That should be your name.
I typically use my username so it doesn't confuse.
That's the thing that is going on your mix to contribute to yourself.
Right.
There to put your actual name, so you connect to yourself.
So, right.
Your name could change.
Change, right. Also that my username is same as my name as well. So in my case, you're right. You're right though. It's better because your name goes on all your commits that you do. Basically, every change that you make, your name is attached to your change. So if anyone wants to blame you for something that goes wrong, essentially they can spot your name. That's the whole purpose for it as well when you're collaborating. So you can spot what's the mistake, who's responsible for the mistake. It's like that. So in my case, I'm using my username, but you can choose. So I can choose instead to say just this. Well, no, doesn't have to be. So then what we're going to do is set the email as well. So it's a similar format. Use git config global user.email, and you type your email address in. And once this is done, you can type git config list again, and at the bottom you'll see both user.name and user.email are set to whatever values you typed in before. And there are other additional options as well that you can set. So the color.ui is essentially specifies the color of the user interface that you have, and you can change it to whatever you want. I have set it at auto. And the code.editor option here essentially tells you what sort of a text editor that you want to use. If you're working with text, primarily with text, what sort of editor you want to use, and you can set that here as well.
I don't see how you want to
you go here. The second line from the top. That's where I have mine.
Yes.
I think it's also a GitHub thing, I think. It's also a Windows thing.
Sorry, so a quick question.
Yeah.
So we just changed our username. We like told what our name now and use global. Does that mean for all other directories we create?
Yes.
Okay.
It'll be all.
So
it's all set.
So we in principle could have done that before making it.
Yes. Yes. You can set that before making. As long as Git is installed on your computer, and as long as you don't change the configuration settings, those two things are going to be the same for every Git repository you create on your computer. That's the whole idea of changing it to global, which that's the reason I don't suggest doing it when you're working on a server, because you don't want to change, you don't want to put your name on somebody else's Git work or Git repository while they do it. So it's typically not recommended when you're working on servers, whereas when you're working on your own computer, it's okay. Okay, so we'll go to the remote. Now what we'll do is we'll try to connect this repository with the remote repository. So in order to do that, what we'll go through, what we'll do is first, wait. So how many people here have GitHub installed? You have GitHub installed on your computer?
GitHub.
This is how it looks like. How many people have it? Let me just open up. So this is GitHub essentially. A nice GUI for your code. So this is what GitHub looks like. So if you have GitHub, what you can do is you can essentially add your new repository to GitHub to actually visualize it. So basically you go to the left-hand corner, the plus sign here, and create the add button, and you browse through to the documents wherever you have your repository. If I do this, now I can see that my repository is added to GitHub. So it helps, it's good for visualization, not really good for working with, but it's good for seeing changes to files and whatnot.
Have you heard of Git Clone?
No, I primarily use GitHub, so. But I'm sure that there are a lot of other GUIs as well apart from GitHub. So because Git is the important part, GitHub is essentially just on the surface, just a GUI. So it doesn't matter what you have. Okay, going back to the shell. Now, our next goal is to connect this repository with the remote repository that we created on GitHub. So in order to do that, we'll check something called as the remote configuration. So you do that using the git remote /v command, -v command. So once you hit enter, it returns an empty result. It essentially means the git remote has not been set. So what we are going to do is add the repository that we just created as the remote for this repository. So in order to do that, and we'll call this origin, so which is essentially a default go-to name for remotes, GitHub. And what we are going to do is go back to the page where we created a repository, and we're going to copy this link and paste it after origin. So what this essentially tells Git is that the origin is located at this particular URL. So if you type git remote -v again, you'll see that origin is set at that particular URL.
Couldn't we use couldn't we do phone request from the software that we made on GitHub?
You can't do it unless you set the remote. That's the reason remote has to be set before you do the pull request. Is everybody there where I am? Okay. So now, let's say you want to create a new file here. So I'm going to say So let's create a new file. So let's create a new file with these details. So what I'm going to do is ask for my name, my program, research area. And what I'm going to do is I'm going to save this in my new Git repository. Save it as
Where did you put that?
Mike. Here, it's here. Mike Red. You can give any name you want. I just want it to be consistent. Yeah, it was just a text file. Just a text file. Just to demonstrate that how you go about doing it. So notice that you're not touching Git at all now. You're working on your files as you would on your computer. It has nothing to do with Git. All we have done is just saved it in that particular folder. Now, if you go to GitHub,
Sorry. So what's the
Yes.
difference between the downloaded GitHub app and the website?
The website GitHub is your remote repo. The GitHub app is just a graphical user interface for your Git.
Okay, so you don't actually need strictly.
You don't need GitHub. Git is the one thing that you need. And also, again, the remote repo is also not needed if you're just concerned about keeping things local. So essentially, if you just want to keep track of changes on your computer, you don't want to deal with the world outside, then you can do that as well. Git is basically a version control system just locally. GitHub is needed only when you need to have an online backup. Let's say you're working here, you have a different computer at home. So what I generally do is I work on my desktop in my lab. I push all my, do version control on my desktop, and then push everything out to the remote and go home again, download it again. Instead of carrying USB sticks all the way from here to there. That's the whole idea. Yeah. So now what you'll have to first do is, now this particular file that we created is not tracked by Git. So Git calls them tracked and untracked. So that's a Git terminology that we use. So this file is not tracked by Git. So essentially what it means is Git does not know that this file exists. So because Windows knows the file exists, or your Mac knows your file exists, but Git does not know. So what we have to first do is first make sure Git tracks it. So what we do is not to enable it to track it. There are two options that you have to look at now. So one thing, let's see if GitHub actually works. There you go. Okay. So now GitHub, you can see the file. So micred.txt, GitHub can see it. Git can still not see it. Okay, Git cannot see it. GitHub is basically just visualization, so it can still see it. So if you click on it, you can see what's in the file. Anything that's been added is in green, preceded by a plus arrow. If you had removed something, it would have a minus in red. So addition, subtraction. And now what we are going to do is make sure Git knows this file exists. So in order to do that, there are two steps to do it. The first step is essentially called as staging your change. And the second step is called committing your change. So what we'll do is staging this change. So staging is similar to, how would I put it? Think about you boarding your aircraft. So staging is similar to you checking in first. And committing is essentially you boarding the aircraft itself and then flying off. So that's what we are going to do. First, we are going to check in. So we are going to stage. And now to do, the command for that is git add. Now, before we do git add, there's another command that I want us to talk about. It's called git status. This tells you what has happened in your Git repository so far. It tells you what files are tracked, what files are untracked, or what files are staged, what files are unstaged. So if you type git status and press enter, it'll tell you what's there. It'll tell you initial commit, untracked files. So essentially we have only one file and that is untracked. So now what we are going to do is stage the file using git add, and git add is followed by the name of the file, which we saved it as mycred. It's a text file. Once you press it, and if you type status again, you see that it says changes to be committed. So this essentially tells you that this changes of the file has been staged and it's ready for committing. Is everybody clear? Okay. So now what we do is make sure Git knows it. So we'll commit this. And this Git commit would do, but we want to make sure that other people know what you're doing, or even you know, say you come back 2 weeks later, find you have a file, you don't know what changes you have made. Now to make sure you know what changes you have made, you essentially add a commit message to it. So I'd say initial commit. Sometimes I add the purpose of the file if it's some important function that I'm writing, some piece of code that I'm writing. But in this case, we're going to just say initial commit. And once this is done, the file has been committed. So if you type git status again, see that it's empty. Because now Git knows it has already started tracking it.
So what kept me from using it intensively, is that I'm not exactly sure how I can navigate between the different versions. So, for example, I'm writing the code. Right. I change it every day. Right. I commit it every day. Right. That's how you do it. You commit every day.
I generally commit. Depends. Some people, I generally commit every change I make, important change I make. So if I make one important change and that changes the function of the entire thing, then I commit that because it's important. Because if something fails after that, I need to come back.
Yeah, exactly. So anyway, so I change it. I delete something. I think that okay, this method was not very nice. I use another method. I delete the other one. I'm sure that I'm confident that I have it in my version control in my Git. So before I was commenting the codes the lines that I didn't want, and it gets heavy and not beautiful. So now I delete it.
Okay.
But then before I was, I realized that this commenting is really better because when I want to go back, I just take a look to the previous code. But now in this one, I should go back and find which version was it, and go back to different versions, find that, previous one, that previous methods that I wanted.
Right.
Check again.
Right. So that's where the commit message comes into play. The commit message, you have to keep it useful enough that it's easy to spot. So there are things on GitHub's web.
So if you want to go back to method 1 that you use, and now you have changed 3 methods.
Right. Right.
You have changed your code 3 times.
Yeah.
So you go through your messages.
You go through your commit. So there is a function called as Git Log that I'll go through at the end, towards the end, where you can see all the commits on your shell itself. And that'll exactly that you want to. That'll help you get to where you want to go.
We get to that.
Yes, we will go through that. Okay, so now we have committed the change. So one more thing that's left to do is move your changes to the GitHub repository that we created, that we have already connected to this. So this action is essentially called a push action. So the URL has already been set. In order to connect this particular repository with that, essentially use, so it's usually just git push. Since this is the first time we are pushing it, we have this U tag attached to it that enables enables your local repository to be connected to your remote repository. So that's the reason you have this U tag. And the origin is essentially what we name the URL to be. It's basically alias for the origin, for the URL. And finally, master is essentially branch, but don't worry about branches. We are not talking about branches now. So the default way to go is master. So essentially that's where all your commits will go to. So once you do this, now see the change here? It has an equal to sign that essentially tells you that your local repository is the same position as your remote repository. And you also need an internet connection to do this. So don't forget that. Okay, now that we have pushed this thing, so what we are going to do is you're going to go back to the GitHub repository that we created, and you'll see that it was empty before. Now your migrate file is there on GitHub. Yes?
It says invalid username or password.
Did you set the username? No?
It's good.
Yeah, I did.
That shouldn't be happening. Did everybody else get their thing to work? Any issues anywhere?
Oh. Now I'm confused. Yeah. Yes. I don't know why that happened. Maybe it's the password. We have to use the username or something. It's not the one that I.
Yes, those are different. Yeah, not the one that you typed in. Yes, the one you signed up with.
I don't know how to put it. That's use the username.
Is everybody else good? Is it working? Okay. So this is basically what you do to create a repository to make sure Git tracks your file. Another thing is, let's say someone else has a repository or someone else has another file that you want, and you want to keep yourself updated with whatever changes they do. So essentially you want to collaborate with someone else on Git. So that's where an operation called cloning comes into play. So what that does is essentially copy that repository from that particular, say, user A to yourself, and you have same copy as the other person does. So what we are going to do is there should be a link. Okay, there should be a link. Does everybody have access to the UofT Coders GitHub account? Sorry? They should be able to clone? Okay. 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 So what we are going to do is so first thing is, if you guys go to GitHub and if you search for my username, you should find all my public repositories. So if you guys can go to the sandbox test repository, do we see it? Yeah, no, not coded. Yeah, it's not. Sorry? Yeah, but it gets a bit. There's a lot more files than this, so there are other things. Okay. Oh, you copied everything there? Oh, okay. Okay. Okay, so let's go to the UofT coders one.
sandbox like that.
Okay. Okay. So if you guys can go to the UofT coders one, Sandbox 2017. Is everybody here? Anybody not here? Okay.
So just write search UofT coders
Yeah, UofT coders.
and
And-
under repositories or
Yeah, under repositories, there should be something called a sandbox-2017.
I see your name dash get training. You also see my name too. I just put UofT coders, and this is, I got your name. And I have SK sensitive.
Searching, but
Yeah,
So you just change it from here?
yeah, you can do that as well.
Oh, use it. There it is, okay.
because that's something for like
Repositories. Go ahead.
There it is.
And, yeah.
All right, thank you. So,
How can you see
Okay, once you're here, so you'll see this. Anybody not here there? Everybody here? Okay, so once you're here, you'll see this big green button here that says clone or download. So what we'll do is, we'll go, if you click that, you'll get the link URL that we got similar to what we got for Git training. So copy this URL to your clipboard. And once you have done that, now go to another folder. So what I'm going to do is I'm going to go back. And okay, so go to the folder of your choice. Now what I'm going to do is clone this particular repository. So command is git clone, and followed by the URL that you just copied. Now,
to be in a different folder than the Git.
yeah, it's just not to confuse
Oh.
everything. Yeah, put it in a different folder. So it's because it's essentially a different repository.
clone test or something?
You can call it whatever you want.
No,
Because essentially, whenever Git clones it, it will create its own folder for the repository. So even if you do it on the desktop, it will create its own folder called sandbox-2017 and clone all the contents into that folder. So that's what Git does. So you can do it wherever, but still it'll have a folder name that's similar, same as the repository name that you're cloning from. So if you go to your Explorer, you can actually see the new folder. You'll see that Sandbox 2017 is there. So now what we'll do is we'll move to that repository. And we find there are two files that are already in there. So now what we are going to do is, just as you would change any file, we are going to open the folder, and both are text files. And we are going to change the contents of the text file. Okay, everybody has, you can use Notepad to edit it. So I'm just going to add a line here saying, so I've added a line to this particular file. and save it like I usually do, and then I close it. Now, if I go back to the shell, and if I type git status, it'll tell you that the file has been modified. It will also give you hints on what you have to do next. So it'll tell you you have to stage it, and if you don't want to stage it, you can discard the changes as well. Any questions? So now next what we are going to do is we're going to stage it using git add. So the file is so I've staged it. So if you type git status, it will tell you it's ready to be committed. And I have a commit message there as well. This is all I want to say about the file. And it's committed. So if you type git status again, it'll tell you working clean, working tree is clean, because all the changes have been committed.
What is the -m mean again?
-m is the tag for message, commit message. So that's what M refers to.
And yeah, and now you want the version on GitHub to change as well?
Yes, no, I haven't pushed it yet. So I just want to show. Okay, so if you look at this, so this is the file that we had before. So this is all. This was the contents of the file before. So now what I'm going to do is first check the remote. So one of the things that happens when you actually clone a repository is the remote configuration is already set. So if I type git remote p, see that the origin is already set, the repository you cloned it from. So I don't have to do the git remote add origin again. So that is one difference between what we did earlier and what we are doing now. And which means we can directly use git push. Other thing is, since you clone the repository, you don't have to use the -u tag because it's already connected. It's already tracking. Your local repository on your computer is tracking what's on the cloud, on GitHub. So you don't have to use the -u tag. So all you have to do is git push origin. Okay. I'm not a contributor there, so you can push it directly. You'll get a fatal error if you try to push it there. Yeah, so this means, can I really say what? This is a safety mechanism because if you're not a contributor to a specific repository, you can't push your changes. This essentially protects what's in the cloud from other people interfering with what you have, instead of random people changing random stuff, right?
What I have in my own, I clone sandbox on my.
On your sandbox, it has changed, but on UofT Coder sandbox, you cannot change it because you don't have permissions to change it. That's the reason I get this error, right? I get this error as unable to access because I don't have permissions to access it. But one thing I want to show is, though, now that we have committed the change, what I'm going to do is I'm going to use the Git Log option that I mentioned before. So Git Log tells me all the commits that I have made to the particular repository, all the commits that have been made to the particular repository. So if you type git log inside your repo, you'll get every single commit that has been made so far. So there should be 4 commits, 3 old commits, press 1 new commit that you guys made. Now this can be made into a much cleaner version using the one-line option. So you type git log /1 line. Do that, give you a much more cleaner version of the commits ID and what the commit message was for each of those commit IDs. So this goes back to your question of how do you actually track it? Okay.
Can I have a version of this sandbox on my GitHub now? I don't want to push it to the origin, but
Yes.
I want to have a version for myself in my class.
Yes. Yeah. What you can do is you go through the same process that we did earlier. So you create your own repository first on GitHub, then copy the link, change the remote using git remote or add origin, or say you want to give it a different name. Say you want to give my origin instead. You can do that and add the link to it, and then that will be set.
You can also just do Git work, GitHub support, copy the complete repo, save in everything. The Git history of that repo as well. That's actually.
Yeah, I didn't want to go into that because people seem to be a bit confused about this, so I don't want to go to Git fork. Fork actually helps you collaborate as well. That's a more important function for fork. So all the changes that you make, you cannot directly push things. So you have something called as pull requests. So people who have access to the repository read through your changes, confirm whether it's good or bad, and then they allow it or deny it, depending on whether it's good or bad. So. Okay, and one last command before we are done. So one of the things is, let's go back and open the example file. Let's say I'm making random change. And let's say this change doesn't work out. So you add a paragraph, your supervisor doesn't like that paragraph in your thesis, he wants you to remove it. So what you can do is essentially, if you go back to this here, it'll tell you it's the file is modified. But remember, we still haven't committed those changes yet, right? So you can essentially not take those changes into account. You can not commit those changes and revert your file to back to the old version where this particular line does not exist. The way you do it is using the Git Checkout command. Checkout followed by a period. Well, discard those changes. Throw those changes out. And if you go back, open the file, you see that the changes are no longer there.
What does the dot do?
The dot says, checkout, go back to your previous commit. Discard everything after the previous commit. That's what the dot is for. And the checkout also has, the Git checkout command is way more powerful than that. It's used for other purposes as well. When you create branches, when you're on forks and whatnot, it helps you move between commits. It's way more powerful, but this is one particular use that might be of interest right now.
If I had changed a few files, and
Right.
I had a few files in this,
Yeah, everything. It discards every single, all
if
the.
I want to only discard one and change in one of the files.
Then what I would, generally the way I do it is commit everything that I want, leave out the uncommitted stuff, then remove everything. Let's say you have changed 5 files, okay? You want the changes only in the 4 files, you don't want the change in the 5th file. I'd commit the first 4 files first, then I would use git checkout period on the 5th file.
What's the difference between adding and committing?
So adding is essentially staging, getting it ready for commit. So as I said before, it's similar to you checking into your flight. So you make sure your baggage is complete, baggage is tracked, your immigration is complete, and your security is complete. You're all done, set to board the flight. And committing is essentially you boarding the flight. So the file is ready to be committed, which essentially means it's gone through all the checks. Now it's ready to be committed. That's the whole idea of staging. And also helps you, typically, you can add sections of the file, stage sections of the file, instead of staging the entire file. Let's say you add 10 lines, and first 5 lines serve one purpose, whereas the next 5 lines serve another purpose. You can stage just the first 5 lines, part of the file, and commit that first, and then do a second commit where I stage the next part, next 5 lines, stage that, and then commit it separately.
And so in sense, it's a stage and add.
Yeah, add does the staging. Add is the command used for staging. Yes. Any other questions?
You show us how to revert to the original clone copy. Like I forgot this checkout revert. Like checkout.
Git checkout period. Period essentially discards everything after the last commit.
It's like the previous commits. And then you press Git Log, you go on your.
Oh yeah.
You go on Git Log. And let's say to the Wednesday, October 4th commit. Can you show us how to change the whole file directly back to that commit?
Oh, you want to go back the entire thing?
Save and go back in time.
Right. So I generally use Git Checkout to do that. Git Checkout helps you to check out to a particular commit. So what you do is check out. Let me just close the file. Then all you need is the first few characters of your commit ID, which is this whole long number. So do a 3. Yep.
Yeah. I get sometimes confused between those two. Because I look at checkout using switching branches.
Right.
You're pointing your head somewhere else. What's the difference between you get reset switch?
The checkout that goes, that commits on top of it still exists. But if we do reset, reset hard or stuff, it'll actually get rid of this commits.
So it's generally not recommended to use git reset hard, especially because you lose all the commits that you have on your local repo, at least. So
You could say
make a branch there. That's what I do with Git Checkout. So what Git Checkout does is goes to that particular commit, and you can create a branch out of that commit. Let's say you want to make changes from that commit on. I would make changes there and then merge it back into the main branch.
So essentially, what you got is now you have a new branch.
I know I don't have a new branch. Now I'm at the commit. I'm at the commit. So in order to get a new branch, I'm right here. And now it's a new branch.
And now when you got merged back onto the master.
Now, yeah, whatever changes I make them, then I merge it back to master. From there. And this is a better way of reverting things as opposed to using git reset. At least git recommended way. It depends on people's personal preference, whether you want to burn everything after or not. Okay, yeah.
It depends too if you're trying to sync with like something on GitHub, and you do it in Singapore, then maybe it's
And no matter if you're collaborating, generally reset hard is frowned upon because you're affecting other people's repo as well. Exactly, yeah. Or people might have taken some branch out of some point ahead of you, and now they're struggling back to merge in. So